Hello and welcome back to Business Analytics. This is Hari Rajagopalan, and this will be the last lecture in predictive analytics. And if you, I think you should pay really careful attention to it because your project is linked with this also. So we finished descriptive analytics, and we are coming to the end of predictive analytics. And we're going to talk about how we should do time series forecasting. And this is a complex methodology right now. You're going to look at, you're going to first do static method, and then you're going to use the Winters method. Now remember, this is not the winter halt method that you learned in the previous video. This is the Winters method, so it's slightly different. So pay close attention to the Excel video. So what we are doing is we are looking at the data. We're going to see whether we have trend or seasonality. Then we're going to use the static date method with DeSeasonalized data to find the seasonal indices. This is going to be our initial values, initialization. We're going to use that, and then we're going to use the Winters method to see if our data is adaptive, whether trend, seasonality, or level is adaptive. So here's some demand data for winter clothing from 2001 and 2006. We are going to forecast the demand for 2007. So, and then we're going to decide what kind of forecast we're going to use. Okay, so let's look at the data. The data is too big for us to kind of just put it up here, but let's just plot the data. We've got 6 years of data, and you can see clearly the winter clothing. You start in January, it's pretty high, it drops all the way, and then around September it starts going up all the way and very high in December, and then starts dropping January, February, March, April, really bottom of April, and then it starts climbing up, and then more here. So, but let's break it up and see whether we get cyclical patterns. Here's 2001, 2002 a little bit more. There's a positive trend 2003, 2004, 5, 6. So clear positive trend, clear seasonality. So let's move to Excel and make sure that follow. This will be a long Excel video, about 30 minutes. So pay close attention to how we go about doing this process. So we come to the last part of time series forecasting, and I wanted to do this without from a blank piece of paper, starting from scratch, showing you step by step how you should be looking at forecasting. So the very first step in any kind of forecasting is you collect the data and you essentially do a time series here to see if we can see any trend, any seasonality. And while this whole thing kind of gives you an idea of, yeah, that it looks like there's a season, and since this is 12 months as a season, having it from 0 to 10 axis is very misleading. You should probably change the minimum to 1, major units as 12, minor units as 1, and this kind of gives you a good idea here. So 1 to 12, it's going down, then going up, then going down again, going up. So this gives you a nice idea of what the demand is. There looks like there's a trend, there looks like it's a seasonality. But I can do a better job by creating, and let me start the data. So I'll start with 2001. I have months 1 to 12, and my first set of values are my 2001 data. And then my second round would be my 2002 data, and you can see clearly there is a trend and there is a seasonality. Now let's get the 2003 data, and you can see again positive trend and seasonality. 2004 data. Furthermore, again, there's a positive trend in seasonality. 2005 data. Again, positive. 2006 data. We have 6 years of data. And if you look at this here, let's add a legend at the bottom. It looks like, and let me go back here, format axis. I want 1, 12. That should work. So it looks like things drop from January to March to April, and then May it starts climbing up all the way up to December, and then it starts again. So this is what we have. So is there seasonality? Yes. Is there trend? Yes. And therefore I'm going to start my first method by using the static method. So let me copy this. Let me leave this as it is, and I'm going to copy this here. I'm going to delete these absolutely off. And let's start by deseasonalizing the demand. So deseasonalizing demand, I've got to go here, average, and it will select this entire 12 months, right? And then I'm going to copy this whole thing down. Yep, there you go. Now I know 12 months is here. Now to deseasonalize this demand, this is going to be between 6 and 7 because it's even number, right? So 7 is going to be where my median is. That's the midpoint. And so my deseasonalized demand is going to be the average of these two. Remember the difference between if you have even number of seasons and odd number of seasons. If you have odd number of seasons, let's say there was only 11 here, your midpoint will be 6, and then you just say this is equal to this value. So you just kind of go and put equal to that value, right? But since you have even, you are going to have to copy this down. Be careful. Now when we copy this down, this is not there. Double click on this, again, not there. Double click on this, and this gives you the last two numbers. So now that we have the deseasonalized demand, right? Let's call it deseason. All right. And I will go ahead and get the same formatting here. I would like 2 decimal places here. Okay, so now we have deseasonalized demand. Let's go ahead and create our regression. So regression Y range will be this deseasonalized demand. Don't select anything else. X range is your time. Don't select month. Don't select the season. It's this time, and just select enough time that you have for this, right? There are no labels. Let's go ahead and put this in a new workbook. So this is regression deseason, and this is static forecast, right? So your intercept and slope is right here. Let's go ahead and copy this. I'm just going to go ahead and move it somewhere here. And let's call this level and trend. All right. So this is level and trend. We can move it later. So we've got level and trend here. And now we're going to essentially run our regression. Right? This is our regression, our trend-based forecast. So this is going to be level plus trend multiplied by time period. And so we can then go down all the way right up to the bottom. So let's go ahead and format this. That's perfect. Don't 4 decimal places is too huge and we don't want to work, but 2 decimal places is good. Then once we have that, now we have actual divided by your regression, right? I mean, you can call it actual as a percentage of trend or actual divided by regression. And so here you go, actual divided by regression. You can copy this all the way till you have actuals and go ahead and put a percentage value there. All right. So now we can start looking at our seasonal indices, 1 to 12. Let's go ahead and just copy this. All right. So seasonal indices, and we go average if, and we select this whole month range, and we say F4, comma, an average if. Now we select this season here, and if it's true, then it's going to average this, and put an F4 there, click enter, and you copy this down, right? So here are the average seasonal indices. You want to get the average of this, and it's 99.36. You want this to be 100. But let's go ahead and color this, set it up, and get it ready for optimization. All right. So here we go. So now we actually can go into our forecast. Our forecast is we look up, and lookup value is this month from this table here. Don't select the average, don't select level and trend. Put an F4. Now remember here, column index number will be 2, not 3. And then you say false, select that, and you're going to multiply this times your regression equation and to give you your forecast. And bingo, you've got your forecast. Everything is set up. Let's go ahead and format this sheet, and there you go. So we can do our LCL and UCL. Shall we do 95 or 99? I think we've been doing 95 for a long time, so let's go ahead and do a 99%. Oh, but for that we need MAD. So let's calculate our MSC, RMSC, MAD, MAPE, right? And so this is going to be sum XMY2. You're going to have your actual, control shift and down to get that, right? And then here are your forecast. Again, you want to do I2 to I73, okay? And then you're going to divide it by count, and again here all the way up to 73. So this gives you your mean squared error, and since that is squared value, you can't really say what it is, so you take the square root of it, and that gives you root mean squared error. Oops, square root, and that gives you, and so you're about, if these are number of, let's call them number of bags of whatever it is that you're selling. Let's say these are bags of, or let's say these are big crates of winter clothing. So, you know, clothing, the demand goes up in the winter and then drops during the summer. So your average is about 69, you're off by about 69.34 crates. Your MADE is equal to average, and then it's the absolute value of your demand minus your forecast, and your forecast right up to 73. Close parentheses, and that should give you your MAD. And your MAPE is the average, and then again here you have the absolute value, your forecast, your actuals minus your forecast. This is the absolute value, and then you are dividing this absolute value by each one of those divisions by your actuals to get your percentage error. So here we go. That should fix that. And so that gives you about a 4.24% error. Okay. All right. So here we go. So let's, now that we've got that, we can go and say forecast plus norm.s.inv. And since we're doing 99%, we have to look at 0.5 5%. 100% minus 99% is 1%, divided by 2 is 0.5%. Multiplied by, always it's 1.25 multiplied by your MAD. That gives you standard deviation. Let's put an F4 there, right? And then here is forecast plus norm.s.inv, and here it's 0.995 multiplied by 1.25 multiplied by your MAD. Once you have these two, you actually get your confidence intervals. And once you're here, you can easily go ahead and draw your let's go ahead and put our, there we go, and let's go here to select data. I would like LCL to be up, demand to go completely down. So you get LCL forecast UCL, and then you get your demand up there. I also like, if you increase it, you can see the difference. I also like to convert both my LCL and UCL into either dots or dashes. So UCL also black, and they will be in dashes. And demand is in blue. And it's pretty much set here. You can see it's very crowded. In fact, I will take away markers for the LCL and UCL because it's so crowded. Let's see if I can do that. And again here, there you go. So it's still kind of crowded, and we can get rid of the chart title. So here is our forecast, right? Now, if we want to optimize this, this is a static forecast, and now we've got to optimize it. So let's go ahead and run an optimizer. So here we do OPT. We're going to optimize it. So when we optimize it, we've got to copy all of this, not the average. Average should still be a formula, and these are all should be numbers. Okay. So once you have numbers, let's go ahead, look at solver, objective. I always like to minimize mean squared error rather than mean absolute deviation, because mean absolute deviation sometimes from a calculation perspective gives some problems. And so here are the variables. We can put in constraint. Of course, this should be equal to 1. Once we do that, we can run it. And bingo, we've got our static solution. So this is the starting point for the Winters method. And we're going to talk about that now. But here we've got MAP at 4.5. We've got, here is the first initial seasonal indices. We have February to July is under the seasonality, is below average. So for example, in April, it's about 37.22% below average, whereas in December, it's about 60.17% above average, the sales, the demand. So we've got this. And now let's look at the Winter-Halts method. So we're going to use the same, let's go ahead and use this. This data set does not change. We want to find out whether this data is adaptive or not, okay? And that's what we're going to do here. So all of these have level, trend, seasonality, and then your forecast. And of course, then you have your LCL and your UCL. Okay. So let's go ahead and set that up. And we're going to have an initial value, your time period. I'm just going to say this is time period 0, where we can have level and trend values. Now these level and trend values come directly from here. Okay, so let's go ahead and copy these two, and I'm going to paste, and I'm going to go ahead and paste these here. Okay, so let's go ahead and format them. There we go. So we have level and trend, which come directly from the optimization, and your seasonality, your initial seasonality for time periods 1 to 12 come directly from there. So we start off with level, trend, and seasonality from the static method, right? And then we are going to actually calculate and use formulas to update level, trend, your seasonality from here, and your forecast. So let's look at this. As this is slightly different from what we did before, but let's work through it. So the basic formulas for this Winters method is different from the Winter-Holt method you've seen before. So let's review them very quickly. So the forecast is, as you talk here, is previous period's level plus the trend multiplied by the current seasonality, right? Now, don't confuse this with the Winter-Holt method you did before, because this actually is not using the previous year's seasonality. So this is different, and make sure you understand that. So that's the forecast. Once you collect the forecast, we have to calculate your level. And so for that, we need alpha, beta, and gamma. And each one is, let's start off with 10%. All right. So we have 10% for each alpha, beta, and gamma. And so let's start with here. This will be alpha F4 multiplied by the actual from the current time divided by the seasonal factor. So we are removing seasonality from the actual to create the new level. And then plus 1 minus alpha, again F4, and you're multiplying it times this the level plus trend from the previous time. So here you're multiplying it level plus trend. Make sure that the alpha has dollar signs, because when you copy this down, that will actually cause problems if you don't. Beta, trend is going to be beta. Again, you have to put an F4 multiplied by, you have level from current time minus the level from previous time. And then you're going to do 1 minus beta again. Make sure you have an F4. And then you multiply it by your previous time period's level. And that gives you these two. Once you have this, you can copy it down. And let me go ahead and get the things formatted. Let's get the same format for these two. And then again for these here. Seasonality should have a different, it should be percentages, so we won't do that. So this goes all the way, and we can copy this right down till the second year. So this works, and you'll notice second year right now we don't have seasonality, so we need to now calculate seasonality before we can do level and trend. So here we go now, gamma, again F4, and we multiplied by the actual from the same season in previous year, and the same season is season 1, that's here, divided by level from the same season in previous year. And then if you go down here, you'll see 1 minus gamma multiplied by the seasonality from the same season in the previous year. So plus 1 minus, again, gamma multiplied by your seasonal index from that particular year. So make sure you have dollar signs all set up. And once you do that, and so now we are set where we can copy this whole thing down all the way up to this point. All right. So now that we come here, we can copy this down a little bit further, and your seasonality can actually start coming down further to the next year. So you can calculate your seasonality here. However, your level and trend will be stuck there, and so your trend has to be multiplied by the number of time periods it's going to be away from. So here we have level and trend, and then you can copy this all the way down. So I hope you realize that this method is different from what you have learned so far. So far, the winter halt method, which you did, was slightly different, and this is slightly different. Once we have this, you can go ahead and I guess you can copy. We can find out our MSC, MAPE. Let's go ahead and get that taken care of. So MSP is, we have sum XM Y2, your array 1. This is your array 1. And the second array is your actual forecast. And that's your array 2. And then again, your count here would be D3 to D74. And that should be your mean squared error. Your MAD would be, again, we're going to use D3 to D74 and H3 to H74. So we can go ahead and put that in. D3 to D74, comma, H3 to H74. Let's take a look here. And this will be minus here. There you go. And then the final one here, you're going to replace D3 to D74 minus H3 to H74, and then it's divided by D3 to D74. So here is the Winters method, and we can also do your confidence intervals right here. We can copy this, and here we will run an optimization algorithm, which will essentially minimize your mean squared error by looking at the three variables, and then your constraints are that these three are less than 1, and then these three are going to be greater than 0, and you can optimize it. So the question here is, should you use an adaptive method or should you use your static method? So you look at your static method, you have a 4.5%, whereas here it's 3.48%. It looks like your level is highly adaptive, whereas your trend and your seasonality is static. So take a look at your trend. Trend beta of 0, trend is constant. Same thing with seasonality. Your seasonality is not going to change. It's going to be pretty much, the seasonal indices are going to be static. So when you talk about this with this data set, you should then explain that you are going to use the Winters method, and the only reason you're using the Winters method is that your level is adaptive, your trend and your seasonality are not. I hope this helps you with this last part, and I kind of spent a good bit of time with Excel on this because I know this is the hard part of this forecasting method. So if you look at what we ended up doing there, we did a static forecast, and we deseasonalized the data. we generated a regression, we found the forecast, we optimized it. Then we used Winter's model, which is different from Winter's halt model, and then we optimized that. And then we decided, the decision was if alpha, beta, and gamma, all three were 0, then the static method would work. If any one of the three were not 0, we would check to see if the errors were smaller, and then you'd need to justify or explain why you're using the adaptive method. Because any one of them is adaptive, we would need to use the adaptive method and move on. In this particular case, beta and gamma were 0, so trend and seasonality were pretty much static. Level was adaptive. So let's look at the formulas for Winter's model. Again, let's review the formulas. Forecast for the current time. We initialized it using the static method, took the trend, level, and seasonal index from the static method. Forecast for the current time was level from the previous time, trend from the previous time, multiplied by the seasonality in the current time. Level for the current time, you used alpha, and then you used actual from the current time divided by seasonality from the current time. Again, 1 minus alpha. And so here are the formulas, which is also there in the Excel file. So you can go through them, and because I haven't used equations, this should be self-explanatory. So the project, as we talk about for you, is you're going to pick any data, collect data of anything that you're interested in. It could be Apple sales, it could be Chick-fil-A, but collect data. Make sure it's monthly. Make sure you have at least 5 years or 6 years of data. Try and plot it, understand it. And then what I want you to do is to use this method, the static method, and this Winter's method. Definitely do these two. And then use another method you have learned in this class, and then give me a presentation comparing these three methods, or if you use extra methods, that's great. But you definitely have to use these two methods, which are the most complex methods. So we finished descriptive analytics, we have finished predictive analytics, and now we are going to move on to prescriptive analytics. That's the next module. I hope you've enjoyed this, and we'll see you soon at the prescriptive analytics module.